Algebraic proof. The keywords and basics for algebraic proof are as follows. Representing any number with either n or x, any even number is always going to be in the 2 times table, so we will represent that as 2n. An odd number is always 1 more or 1 less than an even number. The term consecutive, meaning one after the other. So let's look at consecutive even numbers and then consecutive odd numbers. If 2n is our first even number, to get to the next even number, we add 2. And again, 2n plus 4, etc. If 2n plus 1 is our first odd number, to get to the next odd number, we would add 2 to that. So 2n plus 3, 2n plus 5, etc. Then it's knowing the terms product, sum, and difference. Product is when you are multiplying the values together, sum, adding, difference, subtraction. And these are the basics of algebraic proof. If we know that, we can answer any algebraic proof question. So our first question is an easier example of algebraic proof. They're giving us an expression and we just need to prove that it is an even number. So what we do is we start by expanding and simplifying our brackets, being careful with the signs. 2n plus 1 times 2n plus 1, 4n squared plus 2n plus 2n plus 1, simplifying to 4n squared plus 4n plus 1. Then we are subtracting 2n plus 1. So I've kept this in brackets for a good reason. 4n minus 2n is positive 2n, and then 1 minus 1, which is 0, so cancels out. Then we go to the second part of the question. We need to prove that that is an even number. Now we know an even number is always a multiple of 2, so we can take 2 out as a factor and then factorise 2n squared plus 1n. So at this point it doesn't matter what goes in the brackets, because 2 is a factor, it is therefore even. This is an example of a slightly more difficult algebraic proof question where you have to do it from a statement. So you need to put together your own proof. Prove algebraically that the difference between the squares of any 2 consecutive odd numbers is always a multiple of 8. So with this second part of the proof, we'll leave that till the end. We'll focus on the starting point first. We want the difference between the squares of any 2 consecutive odd numbers. So if my first odd number is 2n plus 1, my next odd number would be 2n plus 3. We want the squares of those, and then we subtract them. So we're going to go for the bigger one first, take away the smaller of the 2 odd numbers. So now we've put together our statement. It's a case of expanding 2n plus 3 times 2n plus 3, subtract 2n plus 1 times 2n plus 1. That leaves us with 4n squared plus 6n plus 6n plus 9. And we subtract 4n squared plus 1 plus 2n plus 2n plus 1. Collect any like terms. 4n squared minus 4n squared, so they cancel. 12n minus 4n is 8n, and 9 minus 1 is 8. Refer back to that second part of the question. Prove that it's always a multiple of 8. Well, take 8 out as a factor, leaving us with n plus 1. And the same thing. 8 is a factor, therefore always a multiple of 8. This question typically about 4 marks. This question 2 to 3 marks.